So again, we notice that this question says solve. And it's not a proof question. So you're allowed to work on both sides. And we're trying to find the values that work out to make this equal. And once again, we have two different trig functions. We have sine and cos in this equation. So we want to see, is there a way that I can change this to only have one trig function? Now, you can't change cos because there's no relationship directly in an identity between sine and cos, but we know that sine squared plus cos squared equals 1. So I can replace the sine squared with 1 minus cos squared. And we had a question like this. Remember that when we did the quiz review and it had a hint, use sine squared plus cos squared equals 1. And now that you've done a bunch of proving questions, see how much easier it is for you guys to see these things? Like even in the cosecant, you are naturally starting to say, oh, I see cosecant's 1 over sine. And when you see sine squared or cos squared, you start thinking that it's 1 minus cos squared or 1 minus sine squared. So now if we multiply things out here, distribute this 2, we get this kind of equation. What kind of equation is this? Quadratic. So how do we solve a quadratic equation? Make one side equal to 0. I would probably rewrite this with the squared first, minus 3 cos x. Put my like terms together. 3 minus 2 is 1. And this is, of all the factoring ones, I would say this is the easiest factoring question you could possibly imagine. Why? Well, if you put your brackets, you only have one option to get 2 cos squared. It has to be 2 cos x and cos x. And what multiplies to give you your last term of 1? It has to be 1 and 1. So we've had no decisions or no thinking to do whatsoever to this point. That's why this is, I would say, is one of the easiest ones. Now, to get a positive 1, they either both have to be positive or both have to be negative. But in order to get that negative 3 in the middle, they both have to be negative. From here, this means that cos x is equal to 1/2 or cos x is equal to 1. Is cos x equal 1/2 on our pie plate? Yes. What family? Pi over 3. What quadrants? 1 and 4. What about 1? Is 1 on your pie plate? Yes. What values? 0 and 2 pi. Now, again, we'll naturally start to solve things between 0 and 2 pi. And that's why it's a good practice always to look back to your original equation and go, oh, look at the domain here. The domain is only from 0 to 3 pi over 2. That's only quadrant 1, quadrant 2, and quadrant 3. So after I've written my answers down, I have to realize I have to get rid of this one because it was in quadrant 4. And I have to get rid of this one because it's also past 3 pi over 2. So our only answers will be pi over 3 and 0. Ooh, I should check, was 0 included? Because sometimes they don't include a value, but here it is included. If we had 3 pi over 2, you'd have to X that one out because that's not included in the domain. So we always do a check of the domain once we're done, and in this case there's only 2 answers. So again, your practice question for this one is number 10.